What is this? All right. Hello, everyone. It's our first real day of virtual learning. Yay! March 16th. This is class 23. Okay, let's see. All right. Blah, blah, blah. So I figured we could still pray. Let us remember that we are in the holy presence of God. Don't stop until you're proud. We'll skip intention since nobody's here. Holy founders, pray for us. Live Jesus in our hearts forever. Okay. All right. So here is the deal. Extra balancing in practice 3 was already due at 9:30 a.m. on Monday into a Google Doc with photos. Hopefully that has been submitted. We are going to talk a little bit about what's going to happen while we're off, which I'm guessing is going to be longer than 2 weeks, but we'll see. And lab intro, I'm going to explain to you how to do the lab. You're going to do parts A and B of the lab. It's going to be due tonight, which is Monday night. If you're watching this on Monday, by 10 p.m., it will lock you out after that. So make sure it's in. It is a lab grade. It will not be accepted late. No late passes. You should be able to just do it. Okay. On Wednesday, practice 1 is going to be due, and balancing equations. I think we're going to have a little Schoology quiz on Wednesday if I can figure that out on balancing equations. Okay. All right. So logistics. I sent you an update in Schoology to join Remind, which is like a texting thing that some of the teachers use. It just might give you a little way to get a hold of me, maybe a little quicker than email. Even though I'm pretty much planning to be online just about all the time. I'm not going anywhere. I'm pretty much just staying at home to try to stay out of the fray. During any of this stuff, you can either work on paper. Some of you, blocks 2 and 3, and a couple other kids already have the paper copies of everything. If you'd rather work on paper and insert photos, that's fine. If you want to work directly in the document, I will post that each day as well. So you can do that if you'd rather work electronically. The lab, you could go either way. It might be nice to do it electronically, but your call, okay? But either way, I need to get the work from you, all right? Monday afternoon, I'm going to have office hours from 2:30 to 4, so I can answer any questions that you might have about the lab that you will have done during the day on Monday or sooner. There's a link in Schoology in the event and also in the instructions folder, okay? Oh, you would have already found that. Never mind. I was going to show you where to find this, but you already got it, I guess, if you're here. Okay. Let's see. All right. So what you need first before we start is the lab document. So you should either pause this and get it, or you already have it. It's either the paper copy I gave you. You can print a paper copy, or you could open up the assignment and do it electronically in there. Okay. But this is what you need. So pause this if you don't have that in front of you. All right. Okay, so this lab, it's actually lab 1. It's going to be chemical reactions, and we're going to be talking about energies of reactions and chemical reaction types, all right? So the first thing is back to endo and exo that we've done before, and I want to show you a little video clip. But basically, endothermic, you can write this later. Endothermic, remember, is when energy comes into a system. I hope you can see this mouse. If you can't, will you please tell me? And then in an exothermic reaction, energy is released. Okay, remember they're calling it heat here. It's not really good terminology. We're going to say energy is released. Okay, all right, so let me see if I can figure out where I put this video. Okay, and I'm just going to show you this little short video of reaction. So all this is 2 temperature probes where there is 2 different reactions happening, and I just want you to kind of watch the temperature of them. I was going to do this in class, but obviously I didn't. Okay, I can't even see the video thing. How stupid. Okay, let me just make it smaller, I guess.
Here we're going to pour some sodium hydroxide into nitric acid. We do.
Okay, so this is the red one. So watch what's happening to the temperature.
Quite a bit. And then the other one here we have some vinegar. We're going to add a little bit of baking soda.
Okay, that's the blue one. Okay, so here, right here, watch the
CO2 gas coming out there.
The blue.
When we do that, we see the temperature actually start to go down, although not as much as the other. So what we want to be able to do then is we want to be able to go through and analyze what's going on with the energy, both chemical and thermal, for these 2 reactions.
Oops, okay, I think I paused it, but anyway, you saw. Okay, all right, so there was 2 different reactions happening in that video, okay? So let's write down a couple of things about endo and exothermic. So the definition of endothermic and exothermic, if you hopefully remember from before, it's the same thing, all right? Endothermic means energy is put into the system, and exothermic means energy is removed from the system, okay? So go ahead and pause it as we go, right? And then you can write down whatever you need to write down as we go. Okay, so pause. Okay, and then signs of this type of change. So in different reactions, we're going to be looking for certain things that indicate whether it's an endo or exothermic reaction. Okay, endothermic, things that we're going to look for. Energy is coming into the system in some way, which we'll talk about different ways that is in a minute. Endothermic reactions feel cold to the touch. When you touch them, they feel cold to you, right? Because they're pulling energy out of your hand, right? So the surroundings are getting colder as they pull energy out into the reaction, okay? Because if the reaction is colder, then it's going to pull energy in to kind of stabilize, okay? If you must use a Bunsen burner to make it happen, that's a sign that it's endothermic, right? I have to add energy in the form of that heat from the Bunsen burner. And then energy term will be on the reactant side of the equation, okay, which we'll talk about in a minute, okay? Again, feel free to pause whenever you need to pause, okay? So for exothermic, energy is going to be coming out of the system, all right? It'll feel hot to the touch, right? Because the energy is coming out, the surroundings will get hotter, which means it's going to like warm up your hand if you touch it. Okay, and the energy term is on the product side because it's something like that was created in the reaction. There's now more energy there than there was originally. It had to go somewhere, okay? All right, so in terms of endo-exo, you kind of already know what this means, but for endothermic, there's basically 2 ways that an endothermic reaction can happen. All right, and we call those pay me now or pay me later in terms of the energy, okay? So an endothermic pay me now reaction means that you must put in energy to make the reaction happen. It's not just going to spontaneously happen on its own, okay? Usually that's in the form of heating it in some form using a Bunsen burner, whatever, okay? So if you must put energy in to make it happen, it's definitely endothermic, okay? An endothermic pay me later would be like the one we just saw in the video with the vinegar and baking soda. The reaction itself gets colder, so energy comes in from the surroundings to equalize the temperature with the surroundings, right? Because remember, energy is going to flow from hot to cold. So in certain reactions, like the vinegar baking soda one, that reaction, it's going to feel colder, so energy is going to have to come in order to kind of balance the temperature between the surroundings, okay? And that's called endothermic pay me later, because the energy is coming in sort of after the reaction, okay? But it still goes on the reactant side because it's still happening like before, okay? An exothermic reaction is a little simpler. That just means the reaction is going to be hotter than the surroundings, so energy must be released in order to equalize the temperature with the surroundings, okay? And that's something that's going to feel warm when you touch it, all right? Okay, so that's one big thing that we're going to get out of this lab is the whole energy transfer thing, okay? The second thing is chemical reaction types that we have, all right? And there are basically 5 different types of chemical reactions. This is all in the packet. Synthesis, which basically means 2 simpler things are coming together to make a complex thing, all right? This is all written out in discussion 1. Decomposition is kind of the opposite. A more complicated thing turns simpler. Doesn't have to be individual elements, but it makes it simpler. Okay, single displacement or single replacement, sometimes it's called. That is what we saw in the nail lab, right? Where remember the iron and the copper switch places. Okay, double displacement or double replacement is kind of the same thing that's happening, but there's going to be 2 couples to start with, and each couple is going to switch partners, okay? Whereas single replacement, there's only 1 couple and 1 single guy. But double replacement is 2 couples, they both switch to a new partner, okay? And then combustion, which I can't see because every time I touch this, that's not going to work either. Every time I touch it, it goes down. But combustion, we'll see in a minute. How can I get this to go away? Whatever. Oh, there it goes. Okay, the fuel, which is like some kind of hydrocarbon like CH4, C2H6, will combine with oxygen and it makes carbon dioxide and water always. Okay? All right, we'll do a lot more with that, so don't worry. Okay, so this is just what's in discussion 1, so you can just go through this yourself, right? Again, synthesis means building up to something more complex. Okay, even this one called photosynthesis, which you probably heard of, it doesn't necessarily just make one thing, but it gets simpler. Okay, decomposition is breaking down into things that are simpler. Okay, single replacement, one element replaces another. Oftentimes for us, it's going to be metals. Okay, although as you see in this last example, it could be non-metals, but we're probably not going to do that. Okay, double replacement, we're going to do a lot more with this later, so don't worry too much about precipitates. Don't worry about this, but usually this is going to be 2 ionic compounds, and they're basically going to switch partners. Okay, and we'll learn later about when it's aqueous, when it's solid. We're not quite there yet. Okay, and then combustion is anything really that's combining with oxygen. Okay, and those are always going to release energy to the surroundings. Okay, that's going to create energy output, right? Which is why we use it for fuel. We use it to, you know, for cooking or driving your car. Okay, all right. So here's an example of this one. So this is like a synthesis type reaction where I have iron and oxygen combining to make iron oxide. All right, burning in air. All right, so the first thing that you're going to write, each time you do a part of the lab, there's going to be 5 parts. 2 parts are due today, Monday. The other 3 parts you're going to do so-called in class on Wednesday. Those will be due Wednesday night, okay? So here's an example of what it'll look like. You have to write the chemical reaction, all right? And we're going to write the energy term. So that means if it's endothermic, you're going to put the energy on the reactant side. If it's exothermic, it's going to come over here on the product side, okay? So I have iron and oxygen plus energy. Input, probably we're going to have to burn it on the Bunsen burner, is going to make iron 3 oxide, okay? That's the first thing you're going to write. That's in the next little box. You should see it on your lab sheet. Okay, now we always have to balance it. So remember what I said, if you don't know how to balance, it's going to be a really hard time from here on out, okay? So make sure that you know how to balance it. All right, so why don't you try to do it yourself first? Okay, and then I'm going to flip over to the new page so you can pause it. When you're ready, start it back up. Okay, so this should be 4, 3, 2. All right, so everybody's balanced. Okay, the next thing you're going to do is draw particle diagrams. So if you want to hand draw them, that's fine. If you'd rather use the electronic document, I threw this together in Google Drawings really super fast. I actually liked it better than hand drawing, so you might explore doing it electronically if you want to, okay? So you can see here I have 4 iron particles. They're all separated. 3 particles of O2, so I have 2 oxygens connected, and that's going to make 2 sets of this iron 3 oxide Fe2O3, okay? All right, the word equation, we practiced this before. 4 moles of solid iron combined with 3 moles of oxygen gas and energy to form 2 moles of iron 3 oxide. So you need to remember how to name this, okay? And then it's going to ask you what kind of a reaction. This isn't endothermic, pay me now, okay? Because this one is going to require input like from a Bunsen burner, which you'll see in the lab when you actually, well, you won't do it. I guess you'll watch me do it, lame. But you'll see that, okay? All right, so that's what each part of the lab is going to look like. You're going to have to do all of those parts, okay? So what I've done was I made a video. I brought the stuff home with me. I made a video showing me doing each part of the lab, okay? And then you can get the measurements you need and all that kind of stuff. So watch the video just like you did it yourself. Then complete that section of the lab like we just went over the example, okay? And parts A and B are due Monday at 10 p.m. Okay, no late passes, no nothing, no nothing. It just needs to get in. It's going to lock out at 10 o'clock, so don't be late. Do not be late. No, my internet went down. No, too bad. Submit it early, okay? After you do each lab section, you'll notice in the instruction document, I also did a wrap-up, okay, where I'm going to show what the correct answers are, okay? So there's really no reason for this not to be correct, but please, I'm begging you, don't just go in and watch the video and copy mine. You need to try to do it yourself first, okay? Because if you don't do that, if all you do is just copy what I write in videos, then once we get to a testing situation or something, you're going to be in big trouble, okay? So please don't do that. Please work on it. If you want to, FaceTime your friends, work on it together. That's great. That's perfect. I think you should definitely be doing that during this